Present, madam.
Okay. 417,
Present, ma'am.
418,
Present, ma'am.
419,
Present, ma'am.
420,
Yes, ma'am.
421,
Present, ma'am.
422, 422, 423,
Present, ma'am.
424, 424, 425,
Present, ma'am.
426,
Present, ma'am.
427,
Present, ma'am.
428, 428, 429,
Present, ma'am.
430, 430, 431,
Yes, ma'am.
432,
Yes, ma'am.
433, 433, 434,
Present, ma'am.
434,
Present, ma'am.
435,
Present, ma'am.
436, 436, 437,
Present, ma'am.
438, 438, 439,
Present, ma'am.
440,
Present, ma'am.
441, 441, 442, 443, 444, 445, 446.
Present, miss.
From 441 to 445, there is a continuous absent. I'll get it reported. Okay, so 446 is present, right?
Yes, miss.
447,
Present, ma'am.
448, 448, 448, 449,
Present, ma'am.
458,
Present, ma'am.
459,
Present, ma'am.
460.
Present, ma'am.
So the roll call is over. I'll just move on to today's chapter, means today's topic. So moving on to that, this today I thought of starting, yeah, the next topic actually, KVL KCL, but I thought of giving you some more problems because the Ohm's law and the series parallel connection is just not very sound from your side. Many of the problems calculation part is also weak for you. So I'll just give you some more problems on that, and let me see that whether you can solve it on your own or not. So I'll just share the screen for you. Is this visible to you all?
Yes, ma'am.
Yes, miss.
Okay, very good. Everyone, please write down the problem and I'll give the hints of solving because this is solely based on the basic of Ohm's law. So let us just start solving this. Just note down the problem first and let me know whether you can do it or not. I'll just read out the problem for you. Two filament lamps A and B takes 0.8 ampere and 0.9 ampere respectively when connected across a 110 volt supply. Calculate the value of current when they are connected in series across a 220 volt supply, assuming the filament resistance to remain unaltered. Also find the voltage across each lamp. Noted down? I hope everyone has noted down. Is this visible and audible to you all?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, fine. So let me first explain the problem to you. Just listen first. Okay. There are two lamps A and B. Okay. Now two lamp takes two current intakes respectively. 0.8 ampere, the current rating of A, and for lamp B, 0.9 ampere current it takes. So two lamps taking two currents. This much is the first statement when it is connected across 110 volt supply. So the supply voltage is 110 volt. So if for both cases lamp A and lamp B separately is connected to 110 volt supply, then they take respectively the current 0.8 ampere and 0.9 ampere, right? So everyone understood the first statement?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay. So two lamps taking two currents when connected across, when both separately are connected across 110 volt supply. Right. Next, they have asked us calculate the value of current when they are connected in series across a 220 volt supply, assuming that the filament resistance to remain unaltered. Also find the voltage across each lamp. Means they have asked us, okay, for these two lamps, in the first statement only, we went to know that 110 volt is the supply voltage and they take respectively the current 0.8 and 0.9. Then for both the lamps, we can calculate the filament resistance of the lamps, right? The resistances we can calculate. Voltage is given, current is given, right?
Yes, ma'am.
Okay. So voltage is given, current is respectively given to A and B. So we get the resistances of A and B first, right?
Yes, ma'am.
Yes, ma'am.
We can use Ohm's law.
Yes, so we get the resistances first. Now, with the help of resistance, we have to find out, they have asked, calculate the value of the current when these two are connected in series. So, first, resistances are separate, resistances are found out first. Next is, if those two resistances or the lamps are connected in series, okay, if they are connected in series across another voltage, in series across another voltage which is 220 volt, okay, 220 volt if they are connected, then Assuming the resistances to be same, if the resistances are same and they are connected across 220 volt in series, then you find the value of current and the voltage across each of the lamps. Is it understandable?
Yes, ma'am.
Can you solve it, everyone?
Yes, ma'am.
Just try, and then I'll discuss the solution. Just try once. First, calculate the resistance of lamp A, then resistance of lamp B with the first statement only. And tell me the value of resistance of A and resistance of B, RB.
Ma'am, value of RA is 137.5 ohm and RB
Absolutely
is
correct. Yes.
122.2.
Point two.
Right. Right. Absolutely. Everyone is getting the value of RA and RB.
Yes, ma'am.
Please,
Yes, ma'am.
everyone, please calculate it. I want everyone to do it in your exercise books. Not only those people who are answering, those people, total there are 40 joining people. So I want all the 40 people to be responding in the same way. Any queries till now? Any queries to anyone for this step, for the first step?
No, ma'am.
Okay. Fine. Hope everyone is clear with the first step, that how to find the RA and RB. So RA is coming as 137.5 and RB is coming as 122.2, right?
Yes, ma'am.
So if RA and RB are found out with the first statement only, now draw another diagram just like this diagram I have drawn. For separate cases of RA and RB, or the two lamps A and B. Now connect these to draw a diagram, connect RA and RB in series with the voltage that is stated to be 220 volt. They have asked na calculate the value of voltage and value of current when they are connected in series across a 220 volt supply. So draw another diagram where these two lamps are connected in series with each other, okay, in series with each other, and the supply voltage is 220 volt.
Ma'am, value of current is 0.8471.
Absolutely correct, absolutely correct. Okay, I'll show it for everyone. First,
Yes, ma'am.
just let everyone do. If you
Point
draw
eight
the
four is correct.
Okay, right. If you draw the equivalent diagram first, equivalent diagram showing that RA and RB is in series with each other, then you add up the series resistance, means RA and RB is in series. So the equivalent resistance is the addition or the sum of the RA and RB. So that you add up and the total current will be found out by the supply voltage divided by that resistance, equivalent resistance. The person who has solved the current value 0.847, absolutely correct. I'll just show you. See, this is the value of RA and RB. And when you connect the two RA and RB, the two resistances in series with each other, the diagram looks like this across a supply of 220 volt. Correct?
Yes, ma'am.
So hence the current come as I equals to V by RAC, or the equivalent resistance, equals to 220 divided by 259.7. 259.7 is the addition sum of the two resistances. Everyone clear now till now? Any question?
Yes, ma'am.
No, ma'am. Clear, ma'am.
No, ma'am.
Okay.
No, ma'am.
Okay. From the next class, I'll call the names of some people and I want them to answer also. Because I want everyone to give the answer. Not only one or two people, everyone. Okay. So moving on to, this was the current, value of current. What else have they asked for? They asked for that calculate the value of current, and then also they have asked for, to also find voltage across each lamp. So voltage across each lamp means this diagram you see, total supply voltage is 220 volt, but the voltage drop across each of the lamps mean what voltage each of the lamp is consuming, because you see series circuit, so current is same, voltage is not same, right? So voltage drop across lamp A and lamp B has to be found out. How will you find out that?
Multiplying the current with the individual resistance value
Right,
of the lamp.
right, which is nothing but Ohm's law, right? V equals to IR.
A is equals to 110 volts.
No, 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 no. What did you multiply? Just tell me. For voltage across lamp.
0.8 into 137.5.
Actually, you take at least three places after decimal. 0.847 it was coming, or 8471 something it was coming. You take 0.847, then you will get the answer. At least three decimal places you take. Okay. That is why a slight difference is there.
VA
Method is
equal to
correct.
116.46 volt.
Right, right. So you see there is a change in difference. If you take 0.8, she is getting it as 110. If you take three places after decimal means 0.847, you will get 116.4. So it is 6 volt difference. So better you take at least three decimal places. Okay. Everyone getting it? Are you
VB
able?
equal to 103.5 volt. Ma'am.
Right. Absolutely correct. So voltage across lamp A and voltage across lamp B is determined just like this. I am just scrolling, and uh, although you should solve it by yourself, just like the others, but this is how the voltage across lamp A and voltage across lamp B can be calculated. Isn't it simple? But Ohm's law, it only without the circuit, if you see the problem statement, using the problem statement, you have to draw the circuit. Here in the problem, the circuit is not drawn, only problem statement is given. Is it clear for everyone?
Clear, ma'am.
Clear, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Fine. So this is the first problem. Let us move on to the second problem. Everyone has written this problem down, hopefully. If you take your time, you can take your time and just write down the problem. Everyone taken down the problem?
Taken, ma'am.
Okay. When you will come to the college, I'll just see the exercise books of the class attended by you, because then only I can consider it as attendant. Someone please mute yourself. Someone please mute. Someone is unmuted. Please mute. Still someone is unmuted. Okay, so moving on to the next problem. Moving on to the next problem, which is this. I'll just show you the problem statement first. This is the problem statement. If the resistance of a circuit having 12-volt source is increased by 4 ohm, the current drops by 0.5 ampere. What is the original resistance of the circuit? I just explained the statement. Suppose if the resistance of the circuit having 12-volt source is increased by 4 ohm. So the current drops by 0.5 ampere. Here in this first statement, just read the first statement. In the first statement, what they have told is that there is a voltage source of 12 volt, right? So 12 volt is a voltage source, and resistance, whatever the resistance of the circuit is, that is increased by 4 ohm, and the current is decreased by 0.5 ampere. So resistance is increased and current is decreased. So what is the original resistance of the circuit? This is asked. So what we will do, we will assume first about the original circuit. So let us original circuit be represented as this. This can be represented as original circuit. So for original circuit, I naught is the current, R naught is the resistance, and V is the voltage that is given equals to 12 volt. So we can write as per Ohm's law, V is equals to I naught R naught. As per Ohm's law for this circuit, the circuit that is drawn, as per Ohm's law, we can write V equals to I naught R naught, where V is equals to 12 volt. So we put 12 in place of V, and we can write this as equation 1, right? Everyone understood till now the original circuit?
Yes, ma'am.
Now, yes. Now in this original circuit, we will apply the first statement. It is said in the first statement that resistance is increased by 4 ohm. So R naught that we have considered here, R naught will be increased like R naught plus 4 ohm, and the current I naught that is shown, I naught will be decreased by 0.5 ampere as it is told in the problem statement. So we will take the resistance, new resistance. This was the original value which is marked as equation 1. The original circuit I naught R naught is equals to 12. This equation is marked as 1, or equation, first equation. So when resistance is increased by 4 ohm, that is R naught plus 4, and the current drops by 0.5 ampere, that is I naught minus 0.5, then as per Ohm's law, there is a new equation V equals to IR. Just put that value in V equals to IR. Everyone understood?
Yes, ma'am.
Okay, I'll just show you what I told. Resistance is increased by 4 ohm. So we take R naught plus 4, means the new resistance is R naught plus 4, and the new current is I naught minus 5. Now you write the Ohm's law, as per Ohm's law, the same equation V equals to IR. This new V, new I and new R is here. New I is I naught minus 0.5 and new R is R naught plus 4. Now you write V equals to I here. Someone please mute. Please mute yourself. Please mute. Okay, I'll see who has not muted. Rajbal. Is this understandable by all?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
Uh,
ma'am.
then you try to form the new equation, which is V equals to IR, where the new I is I naught minus 0.5, R is R naught plus 4. And you do the second equation. Let us see what the second equation becomes. This is the second equation. Now, you have in this second equation, V is the same 12 volt, I naught minus 0.5 is the new current, and R is R naught plus 4. Okay, now you multiply, and this will be our equation 2. So you have equation 1 and equation 2. Equation 1 is I naught R naught equals to 12, and equation 2 is this. So from equation 1 you get I naught R naught equals to 12. So I naught can be written as 12 by R naught. Everyone getting this problem?
Yes, ma'am.
Yes, ma'am.
Please write it down. So can you find out now the value? Original resistance
ma'am.
R naught can you find out? Then try to find out R naught now. Everything else is done here. Find the value of R naught.
Ma'am, R naught value of R naught is 8 ohm.
Absolutely correct. How you have done? Just tell.
I get the quadratic equation in the form of R naught. The equation
Right.
is R naught square plus 4
Right.
R naught minus 96.
Absolutely. Absolutely correct. Absolutely correct. Very good. So what we get from this equation is that, okay, first till now everyone is clear with this. Whatever is done till now, that is clear to everyone.
Yes, ma'am.
Now, do you remember the perfect square method or the Sridharacharya formula that I told in the previous to previous class?
Yes, ma'am.
Right? So that you have to apply now for this quadratic equation. It basically becomes a quadratic equation, which is this R naught. For solving R naught, you will get this quadratic equation. So for this quadratic equation, you apply the Sridharacharya's formula or the perfect square method for finding the two roots of the equation. So the two roots of the quadratic equation you get as this R naught equals to, apply that formula, as you can see, minus b plus minus b square root over b square minus 4ac divided by 2a. So as here in this equation, R naught plus 4 R naught minus 96 equals to 0. So here, as per this formula, we have A equals to 1, B equals to 4, and C equals to minus 6. We just put on the values and we get the two roots or the two values of R naught, which is minus 12 and 8. And since there cannot be a negative value of resistance, so R naught is equals to 8. So is this problem clear to you all?
Yes, ma'am.
Everyone got this problem, means understood this problem? Anyone who did not
Yes, ma'am.
Anyone who did not understand, please raise the question. I don't mind answering you all. Please raise where which part you don't understand. I hope this is clear.
Yes, ma'am.
Okay.
Yes, ma'am.
So fine, very good. So I'll move on to the next problem. Next problem, again, try to do by yourself. I'll tell you the hints. So this is the problem statement. The next problem statement, I'm just reading it out. A 100-watt 250-volt lamp is connected in series with 100-watt 200-volt lamp across a 250-volt supply. So again, there are two lamps. One lamp, the first lamp is 100-watt 250-volt, and the second lamp is 100-watt 200-volt. So these two lamps are connected in series with each other across a 250-volt supply voltage. So calculate the circuit current, voltage across each of the lamps, and assume the lamp resistance to remain unaltered. Means the same resistance you can use to calculate the other. So can you do it? Can you try on your own?
Yes, ma'am.
Just try once and then I'll discuss. What you will do, I'm just telling you in the hint, brief. So you see, first draw the two lamps in series with each other, same as the problem previous to previous problem. That same problem, same kind of problem, you draw two lamps in series with each other. Write down the ratings, which is 100-watt 250-volt for the first lamp and 100-watt 200-volt for the second lamp. So along with these two series lamps connected with each other, the supply voltage is 250-volt. So draw the supply voltage terminals to be equals to V equals to 250-volt. So if you have V equals to 250-volt and the rating of the two lamps you have got, which is 100-watt 250-volt and 100-watt 200-volt. So now you have for each of the lamp, you have power in wattage and you have voltage. So you have power and you have voltage. So you can calculate the resistance. If you have power and voltage, you can calculate the resistance. So calculate the resistance for two of the lamps. For both of the two lamps, resistance of the first lamp you can write as R1, resistance of second lamp you can write as R2. So you find from the rating, that is watt and voltage rating of the lamps, you find out the resistances. First, this you do. What is the formula for finding resistance if you have power and if you have voltage?
P is equal to V
P
square
is
by
equals
R.
to
P
V
is equal to
square.
V square by R.
Absolutely. So use that and find R for the two bulbs.
Ma'am, R1 is 625 ohm and R2 is
R2
400
is
ohm.
200 ohm.
400, ma'am.
400.
Ma'am, R2 is
Right,
400 only.
right. Uh, R1 is 625, R2 is 400.
400.
There may be some calculating mistakes for those who did not get this result. R1, I'm showing this how, okay. R1 is 625 because it is 250 square by 100 and R2 is 200 square by 100. So 250 square by 100 is equals to 625 and 200 square divided by 100 is 400. Just see this, I am scrolling down. This is R1 and R2. Is this clear to everyone?
Yes, ma'am.
Okay. Once you find out R1 and R2, what is our next step? You see, they have asked us about calculate the circuit voltage. This is the first question, and second question is calculate the voltage across each of the lamps. Means R1 and R2, across R1 and R2, what is the voltage V1 and V2. So first, now what we will do for the first part, which is finding the circuit current. So for current, what we will do, current is marked here. I have in the diagram only, whatever it is required, I have written that. Whenever you see the unknown parameters is written, those are the ones we need to find out. So I is equals to question mark, it is written. So I is equals to question I, we have to find out the circuit current. Now for the circuit current, if they have told that these are connected in series, so if the lamps are connected in series, means R1 and R2 are connected in series, the equivalent resistance is R1 plus R2, means you have found out it as 625 and 400. So the equivalent resistance is addition of these two because the lamps are connected in series. So our equivalent resistance RAC is equals to R1 plus R2, that is 625 plus 400, right? Everyone?
Yes, ma'am.
Yes, ma'am.
So, if the series resistance is this, then we have the voltage also given equals to 250 volt. So we can have the equivalent resistance. We have the voltage equals to 250 volt. Now only what we need to do is the current that they have, circuit current, which is I. They have asked I is equals to V by R. Simple,
Ma'am,
right?
0.24 amp.
Right,
0.24 ampere.
right. Absolutely correct. So you just add up these two resistances R1 and R2, and by adding up the resistance you get the equivalent resistance. So divide that resistance in the denominator, resistance will be in denominator, voltage of 250 volt will be in the numerator, find current I, which is equals to 0.244 ampere. Everyone, I just tell you, whenever you get the values in decimal, just calculate up to 3 places of decimal. Means just like you said, 0.24, calculate up to 3 places. So 0.244. Okay. Answer is correct, no doubt, but 0.244 means 3 places of decimal if you calculate, then the precision or the accuracy becomes good when any other questions are asked out of that formula. Okay, so we will just I'll just scroll and 0.244 is the answer. Next is the voltage across each of the lamp they have asked. So voltage across first lamp is again V equals to IR formula, Ohm's law. So you just have to write down or calculate the respective, as you have R1, R2 both. You have I also current. So you have the voltage drop across the two lamps. So can you do it? V equals to IR
150.
for the
152.43.
52 points.
yes. 152.5 is the first V1 and V2 is, how much is
97.
V2?
97.6.
Right. Everyone got this answer?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
very good. So this was our this problem. Now I have another problem given to you. Just try solving that. I'll not tell you in detail. I have a hint that I have given. This problem which I am showing now, this is for your homework. Okay, try for that. This is the problem. Is it clear to everyone? This problem is for your homework. Don't do it now. In the later class, I'll explain. Try doing it. I have just given a hint. You try doing it later. Okay, not now. And letting you people to think and do the problem, solve it later. Okay, so everyone clear with today's problems?
Yes, ma'am.
Yes, yes.
Yes,
Ma'am.
ma'am.
Good. So
Yes, ma'am.
I am just sharing everything, the notes and PDF and the video for today's class. Go through it, and because in the upcoming class I am going to go in detail to the next topic. So I want everything to be cleared now only. The basic concepts of everything related to electrical circuits, that is voltage, current, resistance, power, series, parallel connection, everything till now whatever we have done, it should be clear. Go through the problems, then only it will be clear. Okay, so
Ma'am, please go to the last problem.
yes, sure. I'll share this in the group also, the PDF. You take your time.
Thank you, ma'am.
Okay, fine. Very good. So I'm sharing the notes, the PDF, the lecture video with you all. Go through it, and I'll end the class.
Thank you, ma'am.
Yes. Thank you,
Thank you,
everyone. You can leave. I am
Thank
also
you, ma'am.
Thank you,
everyone.
ma'am.
Thank you,
Thank you.
ma'am.
Thank you very much. Thank you.
Thank you, ma'am.
Thank you, ma'am.